Hi everyone, welcome to my channel. Today we will learn about two emission processes, fluorescence and phosphorescence. Both these processes are the radiative decay process where the molecules make the transition from the excited state to the ground state. If we look into this emission intensity graph, the fluorescence is the rapid decay process while the phosphorescence is a slow decay process. So let's begin with fluorescence. If we look into this Jablonski diagram, each fluorescent molecule has an associated ground state and the excited state. So this is a potential energy curve for the ground state with its associated vibrational energy level, and this is the excited state along with its vibrational energy level. So firstly, the molecule absorbs the radiation, undergoes the absorption, making a transition from this ground state to this excited state. Now once it is in the excited state, what is happening is these molecules can undergo collisions with other molecules. So all these surrounding molecules will make the collision process, and as a result of this the energy will be lost, which results in this decay process known as vibrational relaxation. And due to vibrational relaxation, the molecule from this higher vibrational energy level, it comes to the lowest vibrational energy level corresponding to this excited state. Now once it reaches there, the molecule comes back to the ground state emitting the radiation, and that radiative process is known as fluorescence. So this is how this mechanism takes place. Now the question arises why there are vibrational energy levels associated with each electronic state. The reason is, if we look into this molecular energy level values, the electronic transition is of the order of 10,000 to 100,000, while the vibrational transitions is of the order of 300 to 3000 centimeter inverse. Which means that every electronic transition will be associated with the vibrational transitions, and that is why each electronic state has associated vibrational level which undergoes vibrational transitions as well. So this is in combination with vibrational and electronic transition. Now let's understand about phosphorescence method. So what happens in phosphorescence technique, it's a long-lived emission, and this happens because of the presence of triplet state. Now there are two ways the electrons can be arranged. One is a singlet state where the electrons are paired, and one is a triplet state where both the electrons are of same spin. So most of the molecules has ground state which is singlet. But some of the molecule like oxygen has a triplet state. Now let's first understand about phosphorescence process. So when you look into this Jablonski diagram, again the first method is, what is happening is this is the ground state of the molecule and this is the excited state. The excited state has both singlet states and the triplet vibrational energy levels. Now again, this ground state has associated vibrational energy level corresponding to it. V0 means the ground state, then 1 and 2. And similarly, this is the vibrational energy levels for the singlet state. So when the molecule absorbs the radiation, it undergoes transition from the lowest vibrational state of this ground state molecule to the excited state. So again, these molecules can undergo collisions with other molecules, surrounding molecules, resulting in this vibrational relaxation. So this leads to loss of energy, and what is happening is during this vibrational process, some of the molecules can undergo the intersystem crossing from singlet state to this triplet state. And again, as soon as it reaches to the triplet state, again it undergoes collision, leads to the vibrational relaxation till it reaches to the lowest vibrational energy level state for this excited state. Now once it reached to this triplet state, which is again lowest vibrational energy level, it comes back to the ground state, emitting the radiation. And this is known as phosphorescence. So what is the important point which distinguish? Phosphorescence takes place from triplet state, which is for excited state of the molecule, to the ground state, which is singlet state. On the other hand, if I want to know what is the fluorescence using the same Jablonski diagram, again the molecule is in the singlet state, it undergoes transition to vibration, comes to this vibrational relaxation, reaches to this lowest vibrational energy level, and it emits this process. So this singlet to singlet transition will be fluorescence. And because singlet to singlet is a rapid transition, that's why fluorescence is a fast decay process, while triplet to singlet transition is a slow decay process, which is phosphorescence. Now, if you're able to follow both the processes, fluorescence and phosphorescence, let me ask one quick question. So, does the energy associated for absorption and this emission process, whether it is fluorescence or phosphorescence, is the same? So if you think about it, the question is the energy for this absorption process is same as compared to this emission process? The answer is no. Why? Because as you can see here, some of the energy is being lost during vibrational relaxation. Now, because of this loss of energy during vibrational energy, the net energy for fluorescence or phosphorescence is lower than the energy during the absorption process. And as we know that the wavelength is inversely related to this energy. So E is hc by lambda. So E is inversely proportional to the lambda. E means energy is inversely proportional to lambda. So that means if the energy for fluorescence and phosphorescence is lower, the wavelength is longer associated to this process. And that's why you always observe fluorescence and phosphorescence at longer wavelength as compared to the absorption phenomena. I hope you understand this. Thank you for watching.